268.9 bar, one number that just shattered Russia's 30-year dominance. America was so dependent on Russian rocket engines that we paid them $10 million per engine for our own military launches. Then SpaceX did the impossible. But how did Elon Musk's team crack the code that stumped NASA for decades? What secret fuel gives Raptor its insane power? And why are the Russians suddenly scrambling to catch up? Let's dive right in. Picture this nightmare scenario. It's the height of global tensions, and America's most classified military satellites can't reach orbit. Why? Because we ran out of Russian rocket engines. This wasn't science fiction. This was America's reality for over 20 years. It started innocently enough in 1995. The U.S. Air Force had a brilliant plan: spend $1 billion on the next generation of American rockets. Boeing got the contract for Delta IV. Lockheed Martin built the Atlas V. Both companies had one tiny problem: they had no engine powerful enough to make their rockets work. Meanwhile, across the globe, Russia was sitting on a technological goldmine they'd inherited from the Soviet space program, the RD-180 engine. This wasn't just any engine, it was a monster that could generate power levels that made American engines look like lawnmower motors. Here's where it gets crazy. The RD-180 uses something called oxygen-rich stage combustion. Think of your car engine. It burns fuel once and throws away the exhaust. But the RD-180? It burns its fuel, captures the exhaust, and burns it again in the main chamber. It's like getting twice the power from the same amount of gas. The chamber pressure hit 24.5 megapascals. To put that in perspective, that's like trying to contain the pressure of 3,500 pounds per square inch. Enough to crush a car. The metal had to be coated with special ceramics just to survive. But here's the betrayal nobody talks about. America promised they'd only buy a few engines, learn the technology, then build their own. They lied. For the next 2 decades, every single American military launch, every spy satellite, every classified mission, depended entirely on Russian engineering. The cost was astronomical, $9 to $10 million per engine. But money wasn't the real issue. Dependence was. What if Russia decided to cut America off during a crisis? The entire U.S. space program could be held hostage by Moscow. Then this tech billionaire with zero rocket experience showed up. While Boeing and Lockheed Martin were writing $10 million checks to Russia, Elon Musk was building rockets in a Texas field. The establishment laughed. Rockets aren't software, they said. You can't just iterate your way to space. Musk saw what they missed. The problem wasn't just power, it was economics. The RD-180 was designed as a throwaway engine. Use it once, throw it in the ocean. That's fine when you're launching twice a year. But what if you want to launch twice a week? Here's where Musk made the bet that shocked the industry. Instead of kerosene like the RD-180, he chose methane. Everyone thought he was insane. Methane was the fuel nobody wanted to touch. It was complicated, expensive, and unproven. Kerosene was reliable. Every major rocket used it. Why risk everything on rocket fuel that might not even work? But Musk understood something the experts didn't. The future of spaceflight wasn't about single-use rockets. It was about reusability. And reusable engines need to be clean. Think of it like this. Kerosene burns like a campfire, hot and dirty, leaving soot everywhere. After one flight, the engine is clogged with carbon deposits. You'd need to completely rebuild it. But methane, it burns like natural gas in your kitchen. Clean and efficient. Fire it, land it, fire it again the next day. The efficiency numbers tell the whole story. RD-180 efficiency, 311 seconds. Raptor efficiency, 380 seconds. That's 22% better fuel economy. In space terms, that means carrying 22% more payload or traveling 22% farther on the same fuel. But wait, there's a twist that changes everything. Remember that crushing 24.5 megapascal pressure that made the RD-180 legendary? SpaceX didn't just beat it, they obliterated it. 268.9 bar. That's 26.89 megapascals. 10% higher than Russia's unbeatable record. But here's the mind-bending part. That was just their first attempt with a prototype engine they called the mechanical Christmas tree. How did they do it? The answer lies in something called full-flow staged combustion, engineering so advanced that most rocket scientists thought it was impossible. Here's how insane this is. Most engines waste fuel. Even the mighty RD-180 only burns fuel partially in its preburner, then dumps the leftover overboard. It's like pouring half your gas on the ground before starting your car. But Raptor burns 100% of its fuel. It has two separate preburners. One burns extra fuel, one burns extra oxygen. Then both exhausts get fed into the main chamber where they burn again. Zero waste, maximum power. The temperatures inside this engine are literally hellish. We're talking about conditions that would melt steel in seconds. SpaceX had to invent entirely new metal alloys with names like SX500 just to survive inside Raptor's combustion chambers. But here comes the plot twist. While Russia was celebrating their 30-year-old record, SpaceX was already working on Raptor 2. Chamber pressure, 300 bar. That's 43% higher than the engine that already broke Russia's record. And they weren't done. This is where the story gets absolutely crazy. Remember that mechanical Christmas tree, the first Raptor covered in pipes and cables? Look at Raptor 3. When SpaceX first showed photos of Raptor 3, the CEO of United Launch Alliance thought it was fake. "This can't possibly be the entire engine," he said. It looked like SpaceX had stripped off all the outer components. They hadn't. This was the complete, fully operational engine. The transformation is mind-blowing. Raptor 1, 185 tons of thrust, 2,000 kilograms weight. Raptor 2, 230 tons of thrust, 1,600 kilograms weight. Raptor 3, 280 tons of thrust, 1,525 kilograms weight, 50% more power. 25% lighter weight. How is that even possible? Musk's secret philosophy. The best part is no part. The best process is no process. If a component can't break, it won't break. If a system doesn't exist, it can't fail. But the real breakthrough was manufacturing. SpaceX became the world leader in 3D metal printing. Instead of bolting hundreds of separate parts together, they print entire engine sections as single pieces. No joints to leak, no flanges to fail, no weak points to break. The cooling system alone is science fiction made real. Instead of external heat shields, Raptor 3 has cooling channels printed directly into the engine walls. It's like having a circulatory system that keeps the engine from melting itself. The cost revolution is equally insane. RD-180, $10 million per engine. Single-use Raptor 2, $1 million per engine. 10-plus uses Raptor 3. Projected $250,000 per engine. 100-plus uses, do the math. Russia charges $10 million for one flight. SpaceX will offer 100 flights for less money. But there's one more twist that makes this story legendary. While everyone was focused on the technical specs, Musk was playing a completely different game. The RD-180 is the perfect Earth-to-orbit engine. But what about Earth to Mars? Here's the genius move. Mars has a carbon dioxide atmosphere. Add water and electricity, and you can manufacture methane fuel on the Martian surface. Raptor engines don't just get you to Mars, they can refuel there and bring you home. The RD-180 can't do that. Kerosene doesn't exist on Mars. Russia built the perfect engine for yesterday's space program. SpaceX built the perfect engine for tomorrow's. Russia's response has been telling. After decades of engine dominance, they're suddenly scrambling to develop methane engines. Too little, too late. By 2019, the transformation was complete. America went from total dependence to total dominance in less than a decade. But the real story isn't about beating Russia's record. It's about what happens when a private company moves faster than entire governments. In 2015, Congress finally ordered the U.S. Air Force to end Russian engine dependence. They gave contracts to multiple companies: Aerojet Rocketdyne, Blue Origin, SpaceX, and others. Guess who delivered first? SpaceX didn't just build a better engine, they built a better business model. While everyone else was trying to make expensive rockets slightly cheaper, SpaceX made cheap rockets incredibly capable. The numbers don't lie. 2010, America launches 0 rockets without Russian engines. 2024, America launches 100-plus rockets, 0 Russian dependence. 2025. Russia struggles to sell engines nobody wants anymore. But here's the final twist that nobody saw coming. Remember that 268.9 bar pressure that started this whole story? That wasn't even Raptor's final form. Raptor 3 routinely operates at 350 bar. That's 30% higher than the engine that already broke Russia's 30-year record. And they're still improving it. The chamber pressure race was never the real competition. While Russia was optimizing a dead-end technology, SpaceX was building the foundation for a multi-planetary civilization. Want proof? In 2024, SpaceX launched more mass to orbit than every other country combined, including Russia. The question isn't whether SpaceX beat Russia's record anymore. The question is, how did a company that didn't exist 20 years ago completely reshape the global space industry? And more importantly, what happens when they start mass-producing these engines at scale? So there you have it. 268.9 bar wasn't just a number. It was the moment America stopped playing catch-up and started setting the rules. But here's what really blows my mind. This is just the beginning. SpaceX is now building these Raptor engines faster than Russia ever dreamed possible. Mass production, reusability, Mars capability. We're not just witnessing the end of Russian engine dominance. We're watching the birth of something entirely new. But here's the question that keeps me up at night. If a private company can revolutionize rocket engines this fast, what other impossible technologies are about to get disrupted? What do you think is next? Drop your predictions below. I read every single comment. And if stories like this fascinate you as much as they fascinate me, hit that subscribe button. Because trust me, the space revolution is just getting started. $4.2 billion wasted. 2 astronauts trapped in space for months. Boeing Starliner lost control multiple times mid-flight. NASA had to send SpaceX to rescue them because Starliner was too dangerous. But here's the crazy part. Boeing wants to fly again, and NASA might actually let them. How is this possible? What's really going on behind closed doors? Let's dive right in. NASA faces a critical decision. They need 2 companies to fly astronauts to space after the space shuttle retirement. The bidding war begins. SpaceX, the upstart company that barely existed a decade ago, gets $2.6 billion. Boeing, the aerospace giant with 100 years of experience, gets $4.2 billion. Nearly double the money. Why? Because everyone knew Boeing was the safe choice. But what if I told you that the safe choice would become the most dangerous gamble in NASA's history? December 2019. Boeing's first unmanned test flight. The mission was simple. Fly to the International Space Station, dock, and return. Basic stuff for a company that built the Apollo command module. Instead, Starliner burned through fuel like a drunk sailor spending money. A software bug caused the spacecraft to think it was in the wrong time zone. Not kidding. The clock was off, so the engines fired at the wrong time. If astronauts had been aboard, they would have died. A simple software error nearly turned into a human tragedy. NASA wasn't just disappointed, they were horrified. The investigation revealed something shocking. Boeing had over 60 critical problems with Starliner. 60? That's not debugging, that's systematic failure. But here's what really happened behind closed doors. Boeing's engineers knew about many of these problems months before the flight. They chose to fly anyway. Why? Because admitting delay would mean admitting they were behind SpaceX. After the 2019 disaster, Boeing promised NASA they'd fix everything. They claimed they had identified the root causes. They said 2022 would be different, but internal documents later revealed the truth. Boeing was playing whack-a-mole with problems. Fix one issue, 3 more appear. Their testing facilities couldn't simulate real flight conditions. They were learning about critical failures during actual missions. Meanwhile, SpaceX was flying astronauts safely. Dragon had completed multiple missions flawlessly. The contrast was embarrassing. NASA faced a choice: admit Boeing was failing or double down on the $4.2 billion investment. They chose to double down. May 2022, Boeing's second test flight. This time, they actually reached the space station. Success story, right? Wrong. Multiple thrusters failed during flight. The spacecraft's propulsion system had been delayed for over a year because valves got stuck shut. Moisture was getting into the fuel lines, causing chemical reactions that corroded the hardware. Neither Boeing nor their suppliers caught this during testing. They only discovered it when the valves wouldn't open on the launch pad. But NASA was getting desperate. The space station needed 2 different crew vehicles. They couldn't afford to lose Boeing, so they approved the first crewed mission. Think about that decision. They approved human flight on a spacecraft that had failed multiple critical tests. June 5, 2024. Launch day, 2 veteran astronauts, Butch Wilmore and Sita Williams, climbed into Starliner for what was supposed to be an 8-day mission. Instead, it became a months-long nightmare. Minutes after launch, helium started leaking from the propulsion system. Then thrusters began failing. Not just 1 or 2, but multiple units across different systems. The spacecraft was bleeding fuel and losing control. But here's the terrifying part. Starliner lost the ability to control its attitude multiple times. The astronauts couldn't steer properly. They were flying blind in a metal coffin. NASA has ironclad rules. If a spacecraft loses control authority, abort immediately. But they didn't abort. They let it continue to the station. Why? Because the political cost of failure was too high. The astronauts reached the station, but when it came time to return home, NASA made a decision that shocked the aerospace world. They declared Starliner too dangerous to carry humans back to Earth. Let that sink in. The same spacecraft that NASA approved for human flight was suddenly too risky for human flight. So who rescued the astronauts? SpaceX. Boeing's competitor had to save Boeing's crew. The irony was devastating. Starliner returned to Earth empty like a ghost ship. The astronauts who went up in a Boeing spacecraft came home in a SpaceX Dragon. The symbolism couldn't be clearer. After Starliner's empty return, NASA conducted a thorough investigation. What they found was worse than anyone imagined.